Do you guys have the recitation thing downloaded?
Yeah, I have it pulled up.
Okay. Everyone
Yeah.
else? Cool.
Yep.
So, okay. 2 pucks. Oh gosh. Constant force is exerted on each disc until it reaches the finish line. Which, okay. So which one has the more momentum when constant force is being applied?
Well, the kinetic energy is going to be the same, or the velocity is going to be the same, right? So,
Is it the same force? Yeah, it's the same force.
yeah.
The velocities are not the same. Because the velocity would be the momentum divided by mass. Well, the velocities would not be the same because well, they start at 0, and then the net force, the same net force, we'll call it F, is applied to each of them, and one of them has F divided by m velocity, and the other one has F divided by 4m velocity.
That means the momentum, there's going to be... Oh, wait, but then when you multiply velocity times the mass, you multiply velocity times the mass, so the momentum is going to be the same.
Yes, I suppose so. Because, yeah.
Sorry about that. I was in the bathroom.
No, you're good. We just solved part 1.
How's everybody's week gone?
Wow. Oh boy.
It's alright.
Pretty terrible. Oops.
Why terrible?
Oh, I'm getting slammed with a ton of stuff, but it's fine. Back to physics. I think the student is correct.
I just don't know if it's for the reasoning they said.
I mean, mathematically, he's not, like, perfect, but his conclusion is about accurate, and, well, no, his reasoning is, like, his reasoning does make sense.
Yeah.
And that is the reason, and his hypothesis is correct, so...
Would it be... which disc would it be? Would it be the...
No, they're both the same, because when you add the net force... Well, so force divided by mass is the velocities. And...
Oh,
it's the same force. So the velocities are going to be different. But because it's the same force, when you do the momentum update, it would just be 0 momentum plus the net force times whatever the time is.
That makes sense. Okay.
Although, hold on. Oh, wait a minute. No. The student is incorrect because there's a constant acceleration, and because one of them is moving slower, it has more time to accelerate. And
wait.
Is this
What do you
recitation?
mean?
Moving. What?
Okay, so there is a constant force F being applied to both of them until each disc separately reaches the finish line. So we just said that the velocity of disk 1 is faster than the velocity of disk 2 because velocity is force divided by mass. This means that the time it takes for velocity, or time it takes for puck 1 to reach the finish line is less than the time it takes for puck 2 to reach the finish line. At the time that puck 1 reaches the finish line, they both have the same momentum because they both have the same acceleration being applied to them. But once puck 1 reaches the finish line, it stops getting that acceleration, and puck 2 is still receiving the acceleration. If it was just a constant force at the very beginning, then they would both have the same momentum. Does that make sense? What do you guys think?
Okay, so
They're both receiving the same force, right? And force equals mass times acceleration.
Mm-hmm.
So that means the greater mass means less acceleration, though, because acceleration equals force divided by mass.
when you do so the velocity still accounts for the mass, but then I think the whole point is that it's independent of mass. Or
Yeah, but one of them receives more acceleration time. Even though the force is the same, the times are different. So it's F net times delta time. So the delta times are different. So F net is the same because that's what's given to us. And you're right, mass times acceleration. The acceleration of one is smaller than the other one. But counterpoint, if the forces are the same, if the momentums are the same, if and only if the delta times are also the same. If the force is constant.
Because it has more. I know what you mean now. You said it has more time to accelerate, so it's gonna reach the same acceleration.
if it has more time to accelerate, does that mean that it's going to cross the line faster?
No, it crosses it slower.
Because it has more time.
Well, it's the other way around. It has more time because it's slower. And it's slower. Okay. It's slower because its velocity is lower. And the velocity is lower because velocity equals momentum divided by mass. And if the momentums are the same, then the velocity is lower.
But aren't we just focused on momentum itself?
Yes, but we need to use velocity because of the caveat that once they reach the finish line, the force stops.
Okay.
And they even underlined that.
So which one would cross the line?
First would be the lighter one, and that's because velocity is the momentum, or really the force, divided by mass.
Eric, you're recording, right?
Yes. But guaranteed the TAs have stopped watching by now. I can see on the, so I uploaded them all to YouTube because it's the easiest way to do that. I can see precisely how long people watch, and they're all like 2 minutes,
Okay, good.
which is sad.
How long have you been recording for?
Oh, 10 minutes?
Someone go through their like explanation so I can make sure that mine sounds reasonable.
Well, someone else can. I can chime in if you want.
Mine is not very good, but it went like along the lines that since it had more time to accelerate, it's gonna reach the same acceleration that the smaller puck had when they reached the finish line.
Momentum though.
Sorry, what?
What does that have to do with momentum though?
Therefore, since it will reach the same acceleration, therefore it will have the same velocity. Or slightly less velocity, because momentum equals mass times velocity. Wait, actually, if they have the same acceleration at the finish line, and one is 4 times the mass, wouldn't that mean one
No,
has
they
greater-
have different accelerations at the finish line. They have the same F net, and
Okay, so the bigger one has lower acceleration.
right, but it has a higher mass.
Okay.
So at the finish line, so as soon as disc 1 crosses the finish line, their masses are, or their momentums are equal, but immediately afterwards, disc 2 has a higher momentum because the forces are the same, or because the disc 2 is still receiving the force and disc 1 is not.
Could you share your screen again, just so I
Yes.
can like see the reasoning? Because I'm trying to follow, but
Okay.
it's hard to follow sometimes.
You are a-okay. So what I said is the student is incorrect since disc 2 has more time to accelerate as its velocity is lower. This is due to the momentum update equation, and I give the momentum update equation: velocity equals initial velocity plus F net divided by mass times delta time. This means that disc 2 reaches the finish line slower, giving disc 2 more time to accelerate and gain momentum. And then I reiterate, once disc 1 reaches the finish line, which is before disc 2, the momentums are equal, but immediately afterwards the momentums are not equal due to disc 2 still receiving momentum and I didn't finish, and disc 1 not receiving the force anymore. Oh, I guess we have to say what the student's weakness was. Okay, is everyone good with part 1?
Yes.
Elizabeth, are you good with part 1? Elizabeth,
Hear me?
are you... Yes, we can now.
Okay. Yeah, I said I'm good.
Okay. Audrey,
Mm-hmm. Yeah.
Ayush. Ayush,
Yeah.
you
Sorry.
good? Okay.
Yeah.
Sweet. Let's move on to part 2. Basically, we're going to use the momentum principle in abstract terms to, I guess, show what we just talked about.
System would be the pucks, and the surroundings would be just the force applied.
Mm-hmm.
I don't know if it says a hockey stick or what.
No, I think it just says a
It's just
force applied.
force applied, and then
But it is a constant force.
yeah, and then I don't think we have to include Earth or anything like that since
No.
it's a frictionless surface.
Mm-hmm. Which is one of the assumptions we're making. Constant force, no friction.
And we'll probably have to approximate, or for one of the approximations, since it's a constant force, it's going to be V average. I don't know if we're actually going to need this or not, but V average equals V initial plus V final over 2.
Right. I think we're going to be trying to find what that final velocity is. Yeah, the speed of each disk as it crosses the finish line. But I think we will have to... I don't know. We'll see. Okay. Ayush, are you doing this in Word?
Yeah.
If you hit Alt and equals, it brings up a box where you can type in equations and they will be formatted nicely.
Oh, okay. The equation editor, right?
Yes, the equation editor.
Nice. Okay.
And if you happen to know LaTeX, you can use that as well. But the default works for me. Okay, so the momentum equation is momentum equals momentum initial plus F net times delta T. And we want to find the speed of each puck. So
Do we have to divide everything by mass?
I think so, to get velocity. That gives us, yeah, the velocity equation. Which, substituting everything in, would be velocity equals F the force divided by m times delta t, and delta t equals velocity equals distance over time, right?
Yeah.
So time equals distance over velocity. And we solving for velocity. Who, what? Okay. What?
So the distance would be L. L
Yeah.
divided by T, or L divided by V, sorry.
But substituting two velocity things in, I think we're trying to find velocity, so. Distance equals velocity times time. Or, Gosh. Velocity.
Because we're just looking for the final velocity, right?
Right, but we need to have it in terms of mass, force, and L. So we need to we need to find what delta T is. I wonder if we go into the position update. That would be V times, here we go. This might do it. Maybe. So R equals square root of, let's try
Wait, how do you put in the delta with like a shortcut?
slash
So, like-
slash or backslash INC and then hit space.
Oh, nice. Okay.
For all of these, if you hover over, okay, some of them. The heck. Some of them, if you hover over them, they tell you what the.
Oh yeah, they do.
Some,
If you
some
go
of
to
them.
symbols.
Symbols?
Yeah.
Oh, yeah, symbols. Yeah, there you go. Yeah, you got it. So m divided by force times L. Guys, this is totally not right, but I've solved for time as a function of mass, force, and length.
So I get where you get R equals the velocity times the change in time, but how did you get it to...
I substituted V from the previous step into...
Oh.
And the distance is L. That's why I have L on the right side.
Okay.
I skipped a couple steps.
Okay.
Which...
Right back.
Sorry, what'd you say?
You said I'll be right back.
Oh, okay. Oh, thank you, because I would have waited for a response.
Also, the square root is backslash squirt.
Yes, but I wanted the one that... Oh, okay, it actually does do that. My bad.
Yep.
Yeah,
If you want to do like
I-
fractions, you have to put them in parentheses.
Yes. Unless they're single letters, then you don't.
Oh yeah.
What the heck? There we go. That's so funky. Did I do that right?
I'm not really sure if it's like mathematically it is correct.
Well, sweet, that's all I'm looking for.
I just don't know if that's what they're for. But I guess, I mean, that's what makes the most sense.
I mean, if it's mathematically correct, it should be correct.
When doing an average velocity, so I didn't do average velocity. Mm,
But
You
it
know-
does ask for a momentum update.
right, but you know what? I'm gonna solve it again, but this time do v equals, or what? It'd be r equals r initial plus v average.
That's kind of where I was thinking, because I was like, if you need to use length, then you kind of have your like r minus r initial
Mm-hmm.
as L.
Which that'd be final velocity over 2. V over 2 times, once again, your delta time. You're a little stuck. Oh, but v.
Well, but then you solve for delta t earlier.
Right, so v equals times delta t. Wait. We're still going with velocity equals force over mass times time. That's still... Is that still how we get our final velocity?
Yeah.
Neato.
So force over mass times time, like time in the denominator.
Delta t equals... well, if we just immediately substitute force over mass times delta t squared. This is looking vaguely familiar, but the 2, I don't think the 2 is gonna... Oddly enough, I'm gonna be off by a factor of 2, I think. Now that's weird.
Wait. Aren't you supposed to square root your... never mind. You're good. Sorry.
You're fine. Give me one
Oh, wait.
second. What?
Never mind. Go ahead.
Okay, give me a second.
So, you have your f over m is equal to your velocity. But then you have... Oh, wait, never mind. You squared your delta t. I think then we have to go plug in delta t, which we solved for, which is mass over force times length. That one. I think then we plug that in, and then some things will cancel. Oh, wait. Then it just is L equals L. Beautiful. Did that make sense to anyone?
No.
So, like, you see where he has, so L equals force over 2m times delta t squared.
Yeah.
So t is not one of the variables we're supposed to be using, I don't think. So what I was suggesting was plugging in delta t, which we solved for earlier. And then that would just make length equal to length, though. So
We can just solve for length. Actually, no, that would be really bad.
I don't know what's wrong with. Wait, why'd we plug in anything for v? Aren't we solving for v? Okay, yeah, wait a second. No, that's. So we need to plug in delta t, so we have.
The speed of each disk and the time it took for each disk to get there.
Okay, so we're gonna need to use our delta t, but like we're not gonna use it right now. So when we solved for delta t earlier, I think we plug that in, but we don't plug in f over m for f over m times delta t. We don't use that because we have to solve for v. So he like took the v out of the equation. So I don't think that's what we're supposed to be doing. Does that make sense?
Yeah. Should we just solve for delta t in one of the other equations and plug that in with v?
Solve for delta t. If you look kind of in the middle of his thing, of his screen.
Is it the square root of?
Yeah.
Okay, and then we'll need to plug in something for v.
Plug anything in for v. We're solving for v.
Yeah, but we don't have a v in our current equation. Or
Well,
we need to plug in something that has a v.
So if you, start from L equals v over 2 times delta t.
Hey guys, real quick interjection. I'm back. There's a kinematics thing that we could have just looked at. But anyway, did somebody ask a question? I feel like I ignored. Was it Elizabeth?
Oh, that's okay. I think because you took out v and you down.
Well, I'm deleting all of this.
Oh, okay.
This is, yeah, it definitely should be average velocity, but also there's a kinematics thing, so joke's on us. Anyway.
So you took the v, you put v equal to f over m, but we're solving for v.
Oh, whoops, I didn't complete it.
Well, like you should have just.
I deleted it. Yes, there's a reason. The reason I did that is because we have delta time right there. We have delta time in our equation, and we're not allowed to use that as a variable.
Yeah.
So
yeah, but you took out v, which is what we're solving for.
Right, and then
so
I plugged. So I took out v, so I could. Where is it? It's step. Well, these steps will basically be the same, but just it'll be 2m instead of m. So the reason why I took out v was because we needed to solve for delta time. Oh gosh! Oh, now that I started deleting things, it's all out of whack.
Solve for velocity first.
I still have.
Oh, okay, so I have it right here. So I'll walk you through my work. So here, this is our equation. Velocity equals f over m times time. Now, this is technically f over 2m, but I'll get to that in a sec. So when the...
Wait, but I'm talking about lower down.
Yeah, lower down, so this
like
is...
where
this
L
is,
equals...
This is technically...
L equals v over 2.
Yeah, L equals v over 2, then we put...
But why did you move that to force over mass? Because at that point we should be solving for velocity.
Because we still have delta time, and delta time is illegal. We're not allowed.
But we solve for delta time higher up.
Oh, okay. So these are actually two equations. These are two.
Oh, okay.
I said that I was going to solve it twice. people might not have heard me, and that's okay.
I think I
But
might have missed that. Okay.
That's okay. Sorry, I didn't realize that. I solved this twice
Okay.
using 2 different methods, and I found a discrepancy, and I was going to go back. I figured out why, and so I was going back. Sorry.
It's just very confused. Okay,
But
go ahead with.
Right. So, the final answer I think should be something like f over is like 2m. I think it's this 2m stuff because it's f over 2l. Yeah, it's. Oh gosh, I'm just gonna redo the problem. Where are you guys at in this problem?
Same place you're at. I'm
Where
very
you are.
confused.
It will make
Wait,
sense.
but we solved for delta t. Why are we solving for a?
Because okay, we did the problem wrong in the beginning. We're supposed to use average velocity, like Elizabeth said. I think it was Elizabeth who said that. Supposed to use average velocity because it's a constant force. Oop, it went to the other. It should be 2 mass times L. Now I'm just gonna start deleting stuff. And oh, whoopsies. When this formatting works, it's awesome, but when it doesn't, it sucks. Okay, here we go. So our final answer should be something like 2 mass length, or whatever, force over mass times the square root of 2 mass length divided by f. And this is why. I think this should be coherent now. Does this make sense?
Let me go through the work. 1 second.
Right. I can walk you through it if you
Yep.
would rather, if people would rather have me do that.
I think I'm okay. I don't know if anyone else needs to walk through, but I think I kind of understand what's going on.
So did you use the velocity final velocity equals v initial plus f net over m times delta t, or did you just go straight to the position?
I did use this velocity thing. I used this
Okay.
velocity step
To solve
here. No,
for-
I used it here. So I used it in the last step technically, because our initial velocity.
Oh.
Yeah. So
Okay, so you just plugged everything back in. Okay.
'Cause
okay.
yeah,
My
when-
brain is slow today.
No, you're fine. You're
It's-
fine. Once we found, step 1 was to substitute into. I think we're supposed to highlight the final answer. Oop. Step 1 was to use the velocity equation to find to get velocity in terms of any variable. Then we substituted everything we could in, and we found that velocity equals oh gosh, where is there's a step I'm missing that I want to put in. So we found velocity equals just f over m times delta t.
Yeah, okay.
And this is close to being right, but we still have that delta t. So to solve for delta t, we have to get a new equation. I use the position equation, and that uses average velocity because it's a constant force, and the position is L, the final position, and that equals the average velocity times delta time. But now we know what average velocity is. It's force over mass times time. So
Okay.
we then substitute that into the position equation, and now we have position equals 1/2 AT squared, ironically, which is a kinematic equation, which I realized afterwards. But moving on, then we simplify, and we can solve for delta t, which we can then plug back in.
Okay, that makes a lot more sense.
Mhm.
Thank you for explaining.
You're welcome. Everyone else.
Yeah.
Chris.
I'm good.
Cool. What happened to Ayush? His mic is muted.
I do
Oh,
not know.
I accidentally clicked my hotkey.
No, you're good. Okay, you got that?
Yeah.
Neato. Cool. Did everyone have that written down?
Yes.
Yes.
Neat. Okay, part 3. God, how many problems are there? Part 4. and
Just
then
one with a bunch of parts.
And then part 2, problem 2.
Oh, never mind.
Nice. Okay. So when asked which disk has more kinetic energy, the less massive disk is moving faster. Since kinetic energy depends on speed squared, that more than compensates for the lower mass. So it has more kinetic energy than the massive one. Well,
Kinetic energy is 1/2 mv squared.
1/2. Thank you so much. Okay, 1/2 mass time. Yep, there it is. So 1/2 mv squared. Oh gosh, I don't actually know. I think we can mathematically so we know what the masses are. So, or what the velocities are.
So you just plug that into and you compare the kinetics. You just plug it in.
We can
plug
actually
in the mass.
we can actually solve for kinetic energy.
Yeah.
So I think instead of trying to reason here, we probably should just solve for kinetic energy. Why is this all bold? Stop. Squared. Ah. 1/2. That's kind of awesome that we already solved for V, almost as if they were gearing us up for this. Who would have thought?
So, by the way, in one spot you capitalize N, and then now room is lowercase.
Bruh, why you gotta do me like that? Okay.
It might be misinterpreted as different values.
Yeah, you're right. Times. Whew, okay, so this is force squared divided by mass squared times, this would be actually 2 mass length force to the 1 actually is what it simplifies to. No. Yes. So, okay, so 2 times length divided by, okay. That simplifies, holy crap, like a lot.
And then M also cancels.
Yeah.
Completely.
Shoot, I forgot I probably can't do this in one step. So, but now I can. Oh, and the 2 cancels as well. Holy crap.
Dang,
So
I was hoping that it was going to say
equals F.
FML.
length
This
times.
is fine.
I think it's just length times force divided by mass.
Wait.
I had all my masses cancel.
All
Yeah,
of your
masses cancel.
Oopsies.
All of them.
No, you're right.
So it's length times force. Force times length. However you want.
Yep, length times force. That's kind of awesome.
Same for the second, or no?
Do what?
So they have the same energy.
Oh, because the
Because they would cancel still, even if you switch
length.
the mass.
Oh, kinetic energy is just length times force here. Therefore,
So
yeah.
both of them
so
have the same kinetic
Well,
energy.
yeah, but there's gonna be. I don't know 100% if they're gonna cancel because you have the mass underneath the square root.
Oh, shoot. Oh, wait. Hold on. No, wait, sorry. Go on.
So, so like if you actually do the workout, so it looks like it's gonna be like, a fraction times length times force.
Will you say that again?
It looks like it's gonna be a fraction because
Why
of the
don't-
mass. Because if you plug in 4m, there's gonna. I'm not 100% sure. Let me finish working it out.
So
I don't think that matters.
I see what you're saying, and the constants would cancel out too.
Yeah. No, because there would be a 4m up top and on the bottom. So the 4s would cancel out too.
Yeah.
But they're also underneath the square root, which is why I'm not sure they're gonna cancel.
Well, they're squared. The square root is squared.
Oh wait. Okay, yeah.
No, wait.
No, we're all good. I just worked it out.
Okay, good.
Well, because just instead
Because
of
the 4 gets squared, but that's fine.
yeah, well, and also you can, assuming we did everything mathematically correct, you can jump to the final and substitute m with 4m in the final equation. And if you notice, there's no m, so they would be the same.
Oh wait, also why is this true?
Why is it true? Because
Yeah.
Kinetic energy does not depend on mass for this situation.
Okay.
This is what this is supported by the equation for kinetic energy. Yeah. Okay, so solving it was a great idea. That made it easy. Oh, what would we reply to the student? What?
You're wrong. You're all wrong. Just say you're wrong.
To the student, I would reply that they are correct.
Because the student doesn't have Eric in their group.
What their, I don't know. Their weakness is their argument isn't supported by a comprehensive proof. It's just a estimation.
But the student's not correct.
They wait, what?
Because they're
assume
saying that the
that-
kinetic energy is different.
Oh, I didn't
Yeah.
even read that. I just assumed that they said something comprehensive and logical. Wow. Okay. So to the student, I would reply that they are incorrect mathematically, and their weakness is that they. Wow. Okay. Well, whoopsies. Thank you so much. I was not reading the question. Um, Right. To the student, I would reply, next time use a formal proof, so you cannot be wrong.
Perfect.
I'm not saying that. Anyway. Wait, what? Oh, my bad. Okay. Is everyone good?
Yes.
Ayush and Chris.
Sorry.
Yes.
I don't know. Can you hear me?
Yes.
Okay. My mic might be cutting out a little bit.
Okay. You're good though?
Yeah, I'm good.
Fantastic. Let's move on. Apply the energy principle. Wait, what? Did we... To determine the speed of each disk as it crosses the finish line?
It's the same question, just we have to solve it a different way. We have to use 1/2 mb squared.
Oh. Okay. We have to do this compare and contrast junk. Why is this problem so long?
Are these discs or pucks?
It says, I don't know. It
Discs.
says discs, but
Oh. It said pucks.
I've been saying pucks too, it's okay.
yeah. What? Can we steal what we solved for in the previous problem? Or would that be
Yeah.
cheating?
I think that would be fine.
Because I think we have to do that.
Yeah, I think that's good.
Okay, well... Right, okay, so... How we do this is we're going to take the equation for kinetic energy, substitute what values in, and solve for velocity. Great.
Do we also need to say velocity is a lot less than the speed of light as one of our assumptions?
Yes. Force, yes.
What is going on with my dock?
And while we're at it, we should also put in there that we'll assume the pucks are not right near the event horizon of a black hole, because that would change how space-time works.
I hate physics.
I also hate this class.
Wait, for some reason, okay, so like I pressed some random keyboard shortcut, and then like it's showing me all of my past revisions. Like if I like
Oh, is it control something?
Control Shift something, and then like it says like, oh, when I delete like a letter, it'll like show
Yeah,
like a
it's
string.
yeah, it's if you go, is it Control Shift E?
I don't know. That's probably what I ended up
Oh, do
pressing.
you use Google? Do you use Google Docs a lot?
No, not really.
Oh, well, never mind then. Go to Review, and then there should be a button in the middle that says Track Changes.
Yeah, I got it.
Yeah.
Okay, thank you.
You are welcome. That's happened to me so many times.
I'm so confused that
Confused about.
like why like how I ended up clicking that shortcut out of everything. The most annoying one.
I have no clue, but it happens too often.
Do we just ignore resting force then?
Resting force.
The MC squared thing?
I probably would, because we're not trying to find the energy of the system. I mean,
It just said use energy update, so I wasn't sure. Or energy principle.
well, I mean, I suppose what we could do is. No, there's no reason to do that because we would need to know the total energy of the system before we do the rest energy, like before the rest energy would become useful, because we could subtract the rest energy from the system energy and get the kinetic energy and then set that equal to the mass times velocity and blah blah blah. But that's not quite useful to us. So we're gonna steal what we did in the previous problem because that's the only way I get. Does anyone else see another way to do this problem besides stealing from part 3?
Nope.
No.
At least I don't want to think about it.
Okay.
Fair.
Okay. Wait. I'm sensing some funky stuff.
I don't like the sound of that.
It's okay, it's either the exact same or almost the exact same. It is not even close.
It looks similar.
Uses the same variables.
Oh, because we also had the F over M on the outside, so if you like put that inside, if you square it and put it inside, it's the same thing.
Oh, no way. That's hot. Okay. I was thinking about that. That's really cool. I'm gonna. Nah, I'm too lazy. I was gonna go back and retroactively change my work. Well, yeah, I will. Yeah, you're right. That's really cool. Cool, neato. That means that went pretty quickly. Compare and contrast. The results are the exact same. don't know what else to say. There's no really contrasting there.
Oh.
Right. And that only took us
An hour.
1 hour. An hour exactly. Now we can continue. Hold on. Is everyone good?
Yep.
Mm-hmm.
Chris, are you good?
Yes, I'm good.
Fantastic. Let's move on. What is the question?
Is this momentum update again?
What is the speed of the object at this final location?
What?
What?
I don't know why we care. I'm not gonna lie. Like, I don't care about its final location. Okay, yeah,
But-
momentum update.
Gee, I guess so.
Well, no, okay. This might be done slightly different.
Well, we'll need to find her. Well, so it's constant force, so it's average velocity.
Oh, actually, no, this is easier than. We don't need momentum at all. We just need position update because we just solved for velocity. Because
Oh yeah.
it gives us initial and final location and initial velocity.
What is the speed at the final location? So net force. Oh, we can solve for time. What?
Aren't there different forces though? There's two forces, but they're different. This is
That's
a
why. That's why it's better because we can just plug in final. We can just plug in final position and initial position and solve for V. I don't even know if we need the force. Because what do you need? Oh no, we need T.
Well, let's just go through this. So the system is the object. The surroundings, it would be the force, right? Wow, we're already on the solve the problem stage. Nice.
Okay. I forgot to highlight my last.
Oh gosh, numbers. Aren't they great?
Okay, so if we want to use position update to solve for V, we need time. We just need to solve for delta T.
So first off, speed is the magnitude of velocity. And the speed is our distance over time. Alright, so let's say V. Oh gosh, why is it all bold? Why do they
Actually,
make
let's just
everything
use
bold?
the traditional momentum update and position update.
Right, and then I'm guessing things will simplify, hopefully.
Okay, so I don't have a calculator out, but what are you
Right.
typing out?
Oh, just
It's-
just the equation.
Wouldn't it be F net over M delta T?
You are correct. I was testing you guys. You passed.
Wait, what are those equations?
These are the equations for velocity, which is speed. But not really, but yes.
F net delta T over M. Is that this new lecture?
What? Velocity. These are two equations separated by a comma and the word or.
No, the second one. I've never seen the second one. I don't know.
F net divided by mass times delta time?
Yeah, I've never seen it.
It's like
You mean
when you
That's
take
the
the
momentum.
formula and divide by M.
But
By mass.
we used it previously on this recitation.
That's like the momentum update.
If you take the momentum equation and divide everything both sides by mass.
Okay, do we need this though? We can just plug in
Maybe.
our...
Dude, I don't know, man. I was just gonna solve it and
Just writing stuff.
I was just writing. Yeah,
Let's just
legit.
do,
I was just writing stuff. And
let's do a momentum update. I see a momentum update.
all right, so momentum equals momentum plus F net delta t. Cool. So momentum equals initial momentum is, we don't know, but
Yes, we do.
Mass times velocity.
Mass times velocity.
velocity.
Yeah.
Well, velocity is given to us
3.5.
as 3.5. So momentum. I guess I
It's
suppose
350.
350. Oh, thanks, man. I was hoping I didn't have to get a calculator out. So I suppose.
I may be wrong. I just came up with that.
Hold on. Okay, what? So we're given speed, which isn't a vector. Then we're given a force, which is a vector. And another force, which is a vector. Now
Just convert them to...
but that
just take
doesn't
your
work
magnitude.
because counterpoint. What if speed is in the direction opposite of the force vector?
Well, we can assume that we have the magnitude of speed. I don't know.
We do have the magnitude of speed, but we don't have the direction.
Yeah, so does that matter? And
Well, we have the direction. The direction of change in location. Can't we assume that velocity is in that direction?
No, because oh god. Okay, so hear me out. So what? Okay. No, never mind. No, we cannot assume the direction of force because okay, what I was going to say is we have the direction vector of the force being applied and the direction of movement, and if you subtract, oh gosh, vector math, you know that the velocity direction plus the force direction is going to point in the direction of the movement, except maybe not. I'm doubting myself now. This is also seems like way too much work for this problem.
I think we should use the. Why are we not using the position update? Because then we just have to solve for V average.
So, V average.
And then, because we know V initial plus V final is equal to 2, so you solve for V average, and then you set that equal to
2.
Or, so you do
What?
V final plus V initial over 2 is equal to V average.
I think it's...
Which we can... Huh?
I can't... That's a good idea. Delta time. I'm just trying to think about delta time. Did I say words there? I'm not actually sure. I was distracted by the echo.
Oh, is there an echo there?
There was a slight echo. It's fine. It's fine.
And then you delta t using your speed that's given, right? Because you have the initial that's initial speed. But then you can solve for the distance because you're given the two locations. Um, okay, this is really random and really off topic. But Eric, you sound like a guy who does math videos for on boiler exams.
I do math videos. That's
Oh
kind
my
of-
god. Do you do them on boilerexams.com?
No, I'm just kidding. I do have to do a math video like for a class. But I've only done that once.
Oh wait, boiler exams? I started working for them. They're like,
It's really funny.
Wait, really?
yeah. So my friend, like, he knows the people who like started or something. He's like, hey, you wanna like help us? I'm like, sure.
Oh my gosh.
See-
One of the guys sounds just like Eric.
Really? That's really funny. Maybe
I've never been on boiler exams, to be honest.
Maybe I should hit him up. I like the idea, well, but stuff like that is always fundamentally flawed because it's ran by people who are students, and so there are two major flaws inherent with that issue, like with that alone. One of which is the set of classes that are supported are limited by either the people they can get or the classes that each developer has taken, which is a super limited subset of classes. Also, the support for that website, that tool, is going to like eventually like diminish severely once they graduate. So the lifespan of that tool, no matter how great it is like 4 years, less than if they're above a freshman. And if they're not above a freshman level, then the classes they have aren't very like helpful. And if they are above a freshman level, classes are still not very helpful because everyone else is freshmen. So it's a good idea, but it's kind of flawed pretty severely. And until they can get over, unless they have a way to get over those flaws, it doesn't seem like it'll last. But if it's a tool right now and it works for what you're going through, then that's awesome.
Yeah, I don't know.
My class.
Sorry, that was my little rant on
Good.
student-made tools.
I definitely didn't even think about it like that. I definitely was just like, oh, this is cool. They show you a video on how to do it.
Right. Mm-hmm. But like, what's funny is it won't matter to us because we'll use it for a year or two and then be done. So
Yeah.
So I guess it doesn't really matter to us. It'd be the people behind us. Anyway, if the TAs...
Sorry, that was so off topic.
No, you're fine. You're fine. Back to the problem. So we can get the difference in location. Divide that by... Well, if we divided that
given.
by... But there's a force being added.
It's a constant force, though.
Right, so force times delta time. But we don't have that delta time. To solve for time, distance equals velocity times time. So time equals distance divided by velocity. But we don't have that velocity because velocity equals F net times, oh gosh.
I think you're overthinking it.
Maybe I am, but maybe I'm underthinking it.
Wait, we can't just like use the magnitude of force?
No, because counterpoint. So I'm going to give you two situations, and if we use the magnitude of force, they would be equivalent, but if we don't, they would be inequivalent. Situation 1, the speed vector that we're given points in the opposite direction of the applied force. Situation 2, the speed vector points in the same direction of the applied force. One of which they would be additive, so force plus speed. The other one would be subtractive, force minus speed. But if we just use the magnitudes, it would be force plus speed both times, because direction would be not accounted for. I'm not fun at parties. Unfortunately, this means we don't have a clear way to solve this problem. Someone please interject.
So what if you do, like, you say, like, F net is equal to mass or force is equal to mass times acceleration. If you make acceleration change in velocity over change in time, don't the times cancel out? So you're just left with mass times the change in velocity. Do you understand what I'm saying? Does that make sense?
Wait, sorry, repeat that. If velocity is change in...
So if force is equal to mass times acceleration, and we know that acceleration is equal to the change in velocity over the change in time, and F net that's the force, it's mass times acceleration, wouldn't the delta t's cancel out?
Holy heck, maybe. Let's see.
They would cancel, I think.
Okay, so force equals ma, then a equals what you said, dx.
Change in velocity over change in time.
Change in velocity over change in time? Oh.
Yeah.
Wait, position or velocity?
Velocity.
Velocity over change in time.
Yeah. That's ugly. The change in velocity. What's the change in velocity?
Well, change in velocity is we would be solving for v final.
Mm-hmm.
Change in velocity would be
V final minus V initial.
And we're given v initial of 3.5, but then we have the whole direction wackle.
But what if we just like do the problem and like?
But we can't. We're trying to figure out how to do the problem.
Because then we don't have delta t either.
Right.
Yeah, I'm saying the delta t's would cancel. Because if you're doing F net times delta t, like if you plug that in, it's like for your force, like your change in velocity over change in time. If you times that by delta t, the delta t's would cancel, so you're left with the change in velocity.
So you're saying that force would then equal mass times change in velocity divided by change in time, but force is F net, so we have velocity equals v initial plus F net delta t over m, which is really mass times change in velocity divided by change in time. Oops. Divided by mass times delta t. This is about to be real awkward. V equals vi plus.
I think we're supposed to be using position update because it gives you 2 position points. Like it gives you the 2 time steps, or not like time steps, but it gives you the 2
position points. Also, I just want to interject real quickly. Audrey, the equation that the idea you came up with.
Did I?
What's funny?
Oh, no. We don't talk about that. We don't talk about that.
Too many things canceled.
It's fine. I felt like I had a big brain for a second.
Honestly, I thought you had it too.
Now it's gone. It shrunk.
Right.
Oh,
So
it's-
we're gonna get rid of all that.
It was a good effort.
It was. It was.
I just realized that Visual Studio, the icon for like Visual Studio, like just Visual Studio, like on the left, there's like a line, but on Visual Studio Code, the line is missing. Sorry.
Guys, I love our group. Oh my goodness. Ayush, that made my night. Thank you.
You're welcome. Sorry.
Okay.
My brain is dead.
Same. Yeah, I definitely think we have to use, because like they give us 3 different locations. So, I don't know, location update makes the most sense to me. I'm just gonna kind of go for it, and we're gonna see how it goes.
I think we should take the magnitude of force. Because if we can't use any other equation, if F net is going to be a vector and our velocity is going to be a scalar.
Oh wait, and the speed is a scalar anyway.
Yeah, that was the problem we were having because speed was a scalar and F net wasn't. Hold on, I have to throw something away really quick. Sorry, I'm back.
Welcome back.
Okay, so what progress? Yeah, okay.
Yep.
I'm just gonna take the magnitude of force. We'll call it a day. Oh, we don't have time.
Huh?
We don't have the time.
So that speed, which is 3.5, that's not your initial velocity. That's speed is completely different from velocity, or are they the same?
That's our initial velocity. So we can't we can just take the magnitude of force, but then the bigger problem is that we don't have our time. We don't have delta t.
Okay, I found a delta t.
Oh, never mind.
So what I did was I took the distance that it traveled by just subtracting the vectors,
Guys.
and then I did delta t equals distance over velocity.
So, we're
Yeah, but our
done.
velocity is different.
We have we
Dumb. Were you? I was like, he's
Yeah.
probably out there like Googling it.
I was actually asking my roommate, but we whoever said I was overthinking it, you get a gold medal. We were
Yeah.
overthinking it.
Let's go. Okay.
This is the energy principle recitation homework, and we were trying to use the momentum principle. That should have been an immediate red flag. It was not. We should use the energy principle, not the momentum principle. So instead of the principles and concepts, energy principle formula. And the reason we can do this is so we can have we have an initial kinetic energy in the object because we have a mass and a velocity. And then we know what the change in energy of the system will be because work is the change in energy. And work is the force, which we're given, times the change in distance, or change in position, which we're also given. So using those equations, we can do it. And it makes it easy.
Perfect.
So
you learn something new every day.
So we just spent 25 minutes doing nothing. But
Well, that's okay. We had some fun conversation.
we did.
Yeah, so you see, that was my fault because I didn't see this lecture.
It's all your fault.
Yep.
And not the other 4 of us who were also doing.
Change velocity is equal to the final velocity minus the initial.
Finally. Cool. Okay, so gotta delete all this work. Chris, my man, are you still there?
Yeah, I'm here.
Cool. Did you hear all of that explanation?
Yeah, no, I've been here the whole time. I've just
Alright.
been working on it.
Oh, man. Did you get further than us?
I'm not gonna lie. I never used some. I thought this was the energy for that.
So you're done, I'm guessing?
No.
Hmm.
I've also been on my phone, so.
That's fair. Alright. So the kinetic energy is 50 times whatever 3.5 squared is. Somebody with a calculator. 612.
Yeah. Okay.
So the force
Where did you get that force?
from the problem. It was the first force they
Oh,
gave us.
it's the first force. My bad.
Yeah,
Sorry.
you're fine.
Work is force times distance.
Force dot distance. Or dot change in distance.
I love dot products.
Sorry, I don't have a calculator out.
You're fine.
I can do it. It's okay. I got you.
Oh, I'm on my computer. I got 150.
150. I got
Um,
4,980.
That's what I got too.
What I got?
For 250 times 6.
Oh, I was doing the whole dot product.
I did the whole dot product too.
Sorry, Ayush.
Oh. Oh, this is a dot product. Okay, I don't know how to do one without writing it out with the matrix.
Do it with the matrix then. Matrices are vectors.
A mate. matrix. Isn't that cross product?
You can do dot products with matrices.
I would have never thought to do one that way.
Well, if you imagine a vector as a 1 by 3 matrix, or a 1
But I
by,
guess that.
or sorry, a 3 by 1. I don't know how they do that.
Yeah, yeah. I got you.
Yeah. Okay, that's the work
Okay.
of on step 1. So I'll do work sub 1.
This might just be me, but for your change in R, wait, hold on. Let me double check before. Nope, it's our final minus our initial. Okay, glad I didn't say anything. All right, we're good.
Location. By the way, for those of us doing this on Word, the vectors they give us are, you can just copy paste them into the equation. Because they are equations.
Wait, wouldn't that be? Isn't that position?
What?
You put it as work. You put it.
Oh. Yeah, you're right. I don't know why I did that. Well, I do know why I did that. I just didn't see the position. But thank you for catching me. I was about to look foolish. I have to update this.
Well, the last thing anyone here would think of would be foolish.
Well, thank you.
Wait, how do you do the vector symbols that they have?
Oh, I just copy pasted. But the vector symbols are just the angle brackets, like the less than equal, less than greater than signs.
They turn out different. Like they're like wider.
Oh yeah, I copy pasted the. I mean, I don't really. I think it looks the same, but if you wanted to do, it would be. Oh, it's not going to tell us. Hose.
That's fine.
Okay. Yeah. Sorry.
I'll just put it on my clipboard. So I can't.
I'm just,
I got negative 440.
oh, poop. I'm supposed to actually be doing this. I also got minus 440. Joules?
Yeah.
Yeah.
Yeah, I believe so. That's the one thing I'm
That's work as
confident on.
joules.
Units.
It's Audrey.
Units are important.
Right. Change in energy of the system is equal to the work of the surroundings. So the work of the surroundings equals W1 plus W2, which equals that equals, oh gosh, 4540.
then do we plug that into the
So work equals, or wait, rest energy plus kinetic. I think we might also have to find rest energy.
say,
It's just MC squared, which equals
Wait, but don't we
What
not
the
have to
heck?
because well,
Hold on, someone's at my door.
Guys, I'm gonna be honest, I don't think we should do that.
too because it's velocity is a lot less than I think we need to put that in our assumption. Velocity is a lot less than the speed of light.
Right, but also I don't think we should do MC squared because that gives us 89 bajillion joules, and we only have 4,000 joules being changed. Oh, and whenever rest energy is it would cancel out. Aha, here we go. So E total equals E rest plus kinetic initial plus work initial, or plus work. What? Poop. In lecture.
I thought.
Here we go. Plus work. Okay. Energy final equals energy initial plus work. So energy final is MC squared plus the kinetic of final, which equals MC squared plus the kinetic initial.
There you go.
Plus the work, and everything cancels out. So kinetic final equals kinetic initial, which we already found, plus work. There we go. That's how we do it all. Kinetic final equals, what is that? 612.5 plus. Please tell me everyone is not just light years ahead of me while I'm figuring all this stuff out.
yeah, I'm right there with you.
Nice.
I'm right there with you too.
Alright, sweet, thank you.
Yay. Oh wait, now we solve for velocity.
Yeah, now we have to solve for velocity. God, there's a lot of steps here. So, kinetic equals 1/2 MP sub out of room.
Wait,
What was
is
the
our
mass
final
again?
One.
We got 4, 5, 45. No, 5, 1, 5.
Okay. Yeah, we got. Wait, did we get 5152.5?
Wait, what did you just say?
Do what? One. It's all gone. So you're gonna have to excuse me while I try to figure out what the heck just happened.
5152.5 for the kinetic energy.
Here we go. 5152.5. Thank you.
Yeah.
Sorry.
And I got 10.15.
I did too.
I did too.
Why is this all? Oh, everything's being formatted funky.
Wait, how do I do like the squiggly, like approximate equal sign?
Wait, I got 10.15? Is that what you said?
Yeah.
Yes.
Nice. Oh, and that is a great question. I will look. Try and find it. Here we go. It's just
very
slash approx.
confident.
Backslash approx. Meters a second. And we have to highlight it. Do. Very confident. Chris,
Yes.
are you with us? You're silent.
Yes.
Neato.
Sorry.
No, you're good. You're good. I just want to make sure we're not leaving you behind.
On top.
Your grade is my grade.
Fantastic. Create another problem of it. Ah, son of a nutcracker. Okay. I'm gonna steal the lecture one. What is the?
This is the same thing but on ice.
Oh my god. Okay. Hey, we don't have to draw free body diagrams anymore. That's kind of awesome.
Just wait till next week.
Yeah. Oh yeah, what the heck? Why do we have a recitation during an exam week? That's so... This class.
At least you don't have a lab.
Yeah, gee, it saved us like, what, 45 minutes? Woohoo. I suppose all the
Yeah.
due dates, it saved us like 12 due dates, but whatever. Anyway.
And then we had 2 homeworks due last week. What? Or 3. 2 due on Friday? Like the week before the exam?
Yeah, we did have three homeworks due last week. You're right.
And then a quiz too.
Yeah. What is this class? So much work. So much
hate it.
change in kinetic energy. You know? You feel me?
Oh,
Thank you for laughing.
you're welcome. That was a funny joke.
You're just tired. All right.
Oh my goodness, that's not accurate.